Hi students, welcome to Study Smart channel. Today we are going to study chapter 7 of Form 2 Science, Electricity and Magnetism. Let's start. In this video, you will be studying subtopic 7.1 Electricity. Well students, do you know what is energy? All living things need energy. An athlete, a sleeping person, and even when you are studying for your exam. We all are using energy every single moment of life. So, what does it mean by energy? Energy means the ability to do work. The SI unit of energy is joule with a symbol of capital J. Do you know that energy cannot be created nor destroyed? Yes, but energy can change the form from one type to another type. As such, there are various types of energy that exist around us. We have sound energy, kinetic energy, electrical energy, light energy, heat energy, nuclear energy, chemical energy, gravitational potential energy, and elastic potential energy. But if energy cannot be created, where does the energy coming from? What are the sources of energy? Energy can be derived by natural sources or man-made sources. Let's look at the few natural sources of energy. The first source of energy is the sun. Plants using the sun in order to conduct photosynthesis, which is a process that plants making food. Humans using the sun in order to get heat and also light. And at the same time, we can use solar panel in order to convert the solar energy from the sun to produce electric energy. Next, we have the wind. How wind can create energy? Well, when there is a strong wind, it will turn the blades of a wind turbine. This rotation will in turn spin the generators in order to create the electrical energy. The third source of energy is the water. Just like how the wind can rotate the turbine of a windmill, movement of water from a higher place to a lower place can rotate the water turbine, which in turn will spin the generator. The movement of the generator will create electrical energy. How we can derive energy from biomass? Biomass materials such as wood, agricultural residue and animal waste are burned to produce heat. This heat will be used to generate steam which drives the turbine in order to produce electricity. The last natural sources of energy is geothermal. Geothermal power plants generate electricity by using the Earth's internal heat. Firstly, the hot water is pumped from the underground and turned into the steam in a flush tank. The steam produced in the flush tank is directed to turn a turbine. The turbine is connected to a generator, and as the turbine spins, it drives the generator to produce the electricity. After passing through the turbine, the steam is cooled down in a cooling tower, condensing it back into water. The cooled water is injected into the ground through an injection well, allowing the process to start over again. This cycle efficiently converts geothermal energy into electrical energy, making it one of the renewable and sustainable power sources, just like other natural sources of energy. Now, let's look at the man-made sources of energy. We have fossil fuels and radioactive substances. Both this energy involve converting heat energy into mechanical energy in order to drive a generator which will ultimately produce electrical power. As for the fossil fuels such as the coal, oil and natural gas are burned into a power plant's boiler. The combustion will produce the heat which convert water into the steam. The steam will drive the turbine and ultimately produce the electricity. As for the radioactive substances, in a nuclear reactor, the atoms of radioactive material such as the uranium, plutonium and iridium will undergo nuclear fission. This will release a large amount of heat. The heat produced will convert the water into the steam. The steam drives a turbine connected to the generator producing electricity. These are the sources of man-made energy. Let's look at the electrical charges. What are electric charges? Electric charges consist of positive charge, which known as proton, and negative charges, which known as electron. Same charges will repel, while different charges will attract. The attraction and repulsion between these charges are known as the electrostatic forces. Now, let's look at the definition of electrostatic charges. Electrostatic charges are the static, which means that non-moving electric charges that accumulate on an object. An object can become electrostatically charged if it gains or loses electrons. All objects have the potential to exhibit electrostatic charges. In their natural state, most objects are electrically neutral, meaning that the number of proton, which is the positive charges, is equal to the number of electron, which is the negative charges. However, when objects interact, such as through rubbing or contact, electrons can move from one object to another, leading to an imbalance of charges. This results in one object become positively charged and another object become negatively charged. Now, these objects are known as electrostatically charged objects. Well, students, now is the time for some smart knowledge. Do you know that when two objects are rubbed together, only electrons will move? Yes, protons will never move. Those objects that have the same number of proton and electron are known as neutral. Those that gains electron are known as negatively charged, and those that loses electron are known as positively charged. In daily life, the transfer of electrostatic charges can happen when we rub our feet on a carpet or when we touch our pets. Electrostatic charges are also the reason for you to feel electric shock when you touch a doorknob. When you touch a doorknob, there will be transfer of electric charges between your body and also the doorknob that has static electric charges. The device to detect the existence of electric charges of an object is known as electroscope. When we bring in a neutral strip to the device, the gold leaf does not diverge because the positive and negative charges are attracted to one another. However, when we bring in a positively or negatively charged strip, the gold leaf will diverge because the same charges repel each other. The further the divergence of the gold leaf, the higher the quantity of electrostatic charges accumulated. In our daily life, the occurrence of lightning is one of the phenomena that is related to electrostatic charges. The friction between the clouds and the air causes the cloud to be charged with electric charges. Lightning is a result of the force of attraction that exists between the positive charges on the ground and the negative charges in the clouds. In order to avoid this, we have lightning conductor. Lightning conductor is a metal rod placed on a building and connected with the ground below that. The purpose is to offer a low resistant path to the lightning and also to allow it to pass to the ground without impacting the building. Well, students, have you ever wondered why the TV screen becomes dusty quickly even though you have just wiped it clean few days back? This is because the negative charges on the dust are attracted to the positive charges on the TV screen. In order to avoid this, use a microfiber cloth, a type of anti-electrostatic material, so that the TV screen does not become dusty too fast. Electrical appliances require electric charges to operate. Energy that is needed for the electric charges to flow can be generated from sources such as electrical generator, dry cells, and solar cells. Electric current is defined as the rate of flow of electric charges through a conductor. The SI unit is ampere, which is a capital A. Electric current can be measured by using ammeter. Voltage is the measure of how strong the current is in a circuit. It is what pushes the current through the circuit to a device. The SI unit of voltage is volt, with the symbol being a capital V. Voltage can be measured using a voltmeter. Finally, resistance is the ability to resist or limit the flow of current. There are two types of resistor, which is the fixed resistor and variable resistor. The SI unit of resistance is ohm, with the symbol being a capital R. Ohm's law shows the relationship between the current, voltage and resistance. According to Ohm's law, the voltage is directly proportional to the electric current provided other physical conditions remain unchanged. Well students, there is a smart tip for you to memorize Ohm's law. For that, you need to memorize this triangle with the symbols as shown in the video. V on top, I and R at the bottom. Let's say you need to find the voltage. You just need to cover the V and the remaining is I and R beside each other. Which means that in order to find the voltage, you need to multiply the current and the resistance together. If you need to find the current, just cover the I, you will see the V on top and the R at the bottom. Means, in order to find the current, you need to divide the voltage and the resistance. Same goes to resistance as well. Quite easy, right? Good luck! Well students, we have came to the end part of this video. In this video, you have studied energy, electric charges, electrostatic forces and the Ohm's law. I hope you understand everything very well. That's it for today. Until we meet again in the next video, thank you and have a nice day. Bye!